going to be talking about your lipids. In your packet, you actually have two groups as they listed in here as for types of lipids. Hold that thought. I will talk to you about why both groups 2 and 3 in your packet are listed underneath the lipid function. So lipids are fats. If you don't know that already, please stick in your brain the difference between the word lipid and fat and know that there is not a difference. It's the same difference between saccharide and sugar. It's not a difference. It's just two different versions of saying the exact same thing. The function of this molecule is just to be a long hydrocarbon chain. We're going to use it in a lot of different ways, but its primary function is just that of a long hydrocarbon chain, which has a lot of other implications. Fat in and of themselves, it's just a hydrocarbon chain. That's it. That's its whole job, its whole role. It's made out of carbon, hydrogen, oxygen. So same three things that are going to make up your sugar molecule. It sometimes can be a little hard to see the difference between a lipid and a, saccharide carbohydrate molecule if you're not really paying attention. Saccharides are going to have circles, 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 circles. These guys are literally just going to be a long chain. So when you pasted some stuff in here, you should have noticed like, hey, I'm just painting big, long sticks of stuff. Yes, you were. There's a reason that you were pasting those big, long sticks of stuff. So here we go with your monomer polymer. The monomer for this guy is going to be very similar to the way that the monomer is going to be for the nucleic acid. It is not just one part, but it actually has two components that make up the monomer. And if you don't have both components, you don't have the monomer. So in this case, the two things that you need to stick together are going to be a fatty acid. That's very classic lipid, but it can't function on its own. It does nothing by itself. It's just a long chain of fatty acids, has zero functionality, doesn't really do anything. You have to pair that fatty acid with some bit of glycerol. Glycerol is a sugar molecule. So to actually get a lipid that's functional and carries out biological processes, you need both a lipid and a sugar stuck together. So once those two things come together, we call that a monomer. Then there are three classes of polymers, and that's why in your packet it lists them separately as two different groups in there, because there are three different polymers, each serving this like incredibly different function. And if you're thinking like, well, wait a second, there were different saccharides, why didn't they separate those? Because the function is not incredibly different. And you'll see here in a second, it's just three really incredibly different things looking three different ways. Just roll with me here. The first thing that we're going to talk about is how those lipids and that glycerol get stuck together, and the bond formation is going to be exactly the same that it is going to be for your nucleic acids, for your proteins, and then for your saccharides. It's called a dehydration synthesis reaction. So we're taking water out and we're smashing two things together. When we do that in this case, we call it an ester bond. So how we stick those things together is an ester bond. This is how an ester bond works when you are trying to make a triglyceride, for example. So that's how those two things get stuck together. I know you're thinking, okay, cool, then just show us how it's a one-to-one. I can't. There's no time when it's ever just a glycerol plus a fatty acid. It's kind of weird. There's really no true monomer for a lipid. It's the only category where the monomer is kind of a misnomer. It has to be this glycerol plus this fatty acid, but a one glycerol plus one fatty acid is not a thing. So it's kind of a weird, fuzzy monomer thing in here. So I'm going to put it on here because that's what it's made out of, and that's what we call it, and we just kind of like made the matrix work. We wanted to fill in all the boxes, so to speak, but it's not actually real. So moving forward, the first, we'll just go in the order of your packet. So in group 2 for your packet, it talks about cholesterol. If you in your head are like, cholesterol, that's bad stuff. Yes, sort of. There's good cholesterol and there's bad cholesterol. That's diet. Beautiful, love it. Please make sure that you know that. There is also cholesterol that it is necessary for your biological function. Without cholesterol, organisms don't function. Period. End of story. You have to have cholesterol. This is the way the cholesterol looks. That's what the molecule actually looks like. One of your things wanted you to point to the double bond. If you were unsure what that was, hopefully you figured out like, oh, well, there's this one spot where there's two lines. Yep, nailed it. You got it. Here's something else that chemists do that you need to be aware of is chemists are inherently lazy. Anytime when they can take a shortcut, they do. Because in chemistry, if you actually drew out every single element that was in there, in certain molecules, it's cluttered and it's overwhelming and it actually becomes difficult to look at. So, for neatness sake, for simplicity's sake, what they do is they do not draw out every single hydrogen, nor is every carbon listed. If you don't know, at every single one of these points, so right here at the top of the hexagon, at the side of the hexagon, at the side of the hexagon over here, at the bottom of the hexagon, over here at the side of the hexagon, at the bottom of this pentagon, at all of those points, that should be a carbon molecule that is in there. Off of a carbon molecule, there are always 4 bond slots available. It wants 4 friends. Carbon is very friendly. It wants 4 people. So invisibly, there are also 2 hydrogens that are being left open, and you just have to know that those are also in there, that there are 2 hydrogens that are missing off here. There is 1 hydrogen that's missing off here. Every point should have 4 lines. It should always look like a plus sign. It just might turn the plus sign in some way. Anytime that you're like, what goes in the empty slots? That one's over there and it connects to somebody, and that one's over there and it connects to somebody, but like, who goes at the 2 invisible signs? Hydrogen. So really what they wanted you to do is redraw this whole molecule, putting C's and H's all over the place. So if you did that in your head, thumbs up. If you drew it out and now you can see like, oh yeah, that is really cluttered. Yep, you got it. If you want me to take a peek and see if you did it correctly, I'm more than happy to. Also, a quick Google on the full cholesterol molecule, you can see that what the heck it actually looks like, and it's quite cluttered with a lot of carbons and hydrogens. So that is the whole point of that question. It just wanted you to know about the invisible carbon and the invisible hydrogen. They're present. They're not really invisible. Chemists are just lazy because it's cluttered. It's messy. Carbon is a steroids and cholesterol is a very large class of molecules that is necessary. Taking a look at this diagram here, I want you to just notice some of the names. Testosterone, estrogen, cortisol, progesterone. Those are all types of steroids. Those are all lipid-derived elements and lipid-derived macromolecules. It's a huge, huge class of molecules. What it is essentially is it is ring-shaped, so I know that might throw you a little bit because like, oh, it's not a saccharide. I know, I got it. It also throws me a little bit here too. But we got rings that are hooked on here, and those are that's the base for a steroid molecule. So that's what you gotta just keep in your brain here. That's a steroid. Don't worry, I'll always tell you what it is. I'll always be very clear what these things are, but please just know that some of the hormones that are like flowing through bodies at any time are lipid derived things, and we call them steroids. So steroids get a really bad rap. Cholesterol gets a really bad rap. It's just a type of a lipid, and it's necessary for biological function. Now, if you go throwing these things out of whack, we got a problem. If your body starts throwing these things out of whack, you got a problem. Lipids are absolutely crucial for biological function, the kind that you don't want to overeat and put into your arteries, that LDL cholesterol. Yeah, that's terrible. We don't want to do that. It clogs your arteries. It's no bueno. Bad stuff. Don't do that. Normal, everyday, low levels of lipids that you're going to get in your foods and your body is making, that's necessary. You need those things. The second one, and this is that more dietary one that we're going to get into here, are called your triglycerides. And this is where, if you've ever heard of the word saturated and unsaturated fats, this is where that fits in. This is where that functions. So a little bit of information for you on saturated and unsaturated fats. It's the presence of a double bond or the lack thereof a double bond. And hopefully you identified that double bond in the molecules that you were pasting in. I think it gave you 1. What that happens if you ever get a double bonded carbon in there, it puts a kink in the molecule, as you can see in this bottom one. All those kinky ones are more liable to get stuck, are more easily able to flow through you. They are unstuck. They don't get stuck in there. I think of them as like unsticky. So they just kind of move on. You like those ones. That's your avocado, olive oil. sunflower oil, all of your different room temperature oils that are good for you. The oil that comes in peanuts, the healthy stuff, those are unsaturated. If you get too many straight bonds, single carbon to carbon bonds with a ton of hydrogen on there, that is known as a saturated fat. And those are the ones that are really bad that we sometimes manufacture. They're the ones that are a little more delicious. They are the animal fats that come in your steak. It's the 10% if you buy 90/10 ground beef, if you've ever seen that on the package that comes home in your house. That 10% is saturated fat, and it is delicious. It is not good for you. It is room temperature. It is solid at room temperature. You can leave that steak, that hamburger on the counter, and it will not change form. You can leave butter on the counter, and it will not change shape because it is so high in saturated fats. And that's also present in a lot of the foods that we eat, which is why you don't want to eat processed foods, because processed foods have a lot of saturated fats. It makes them stable, which is nice to have things that are stable, but it's also not healthy. You don't want those things because when they get inside of your arteries and veins, they get stuck and they form those blocks and those plaques and those clogs. And that's the difference, saturated and unsaturated fat. So it's a necessary thing. It just naturally occurs in animal proteins. It naturally occurs in plant proteins that are out there that you are consuming on a regular basis. And that's the difference between those. So we do need those. Again, a class of fat that is necessary for biological function. Last and most important is the macromolecule known as a phospholipid. So it's going to be the same glycerol. You can see that word that is right in here. We've got 2 fatty acid chains hanging out the end of there. So we're looking like a lipid here, and we are. But then we're going to chuck this phosphate group into the middle. And that phosphate group is really cool because it enables that structure that's on there. That structure is actually, if you remember, 9th grade bio, we teach this to you. You also, if you've taken anatomy, might have gotten this out of there. That allows your cell membranes to form. So phospholipids, lipid, fat, is why your cell membranes are formed in the way that they are formed. And in our next unit, we're going to talk more about phospholipid bilayer and the components to your cell membranes and the beautiful structure that they work. For right now, I just need you to know, and this is the lipid that's not in your packet. If they did, I think they should kind of resort the packet, but it's a pretty beautiful packet that teaches you a lot of things. So I'm going to leave it alone. But I do think they left out phospholipids, in my opinion. And so just know that phospholipids are an important class of molecule that also needs to be in there. If you have any questions, let me know. I am happy to answer anything that you have. I could talk your ear off about these guys. Lipids are really cool. They do some pretty fun biological function things that's in there.